All right, this is lesson 3.6, geometric proofs. So now this is the big one. This is like the culmination of our whole unit, is being able to write a geometric proof. So I can write a 2-column geometric proof involving segments and angles. So some of our proofs are going to involve just segment and segment addition and things like that, and then others are going to have angles in them. So let's look at some of these here. So some things you're going to use as reasons for our proof steps. You know how you have a 2-column proof system, right, where we got statements on the left and reasons on the right. Well, we need some reasons why we do certain things. And so these are some good reasons that you can use in your proofs, like the definition of congruence. The definition of congruence simply says if two things are congruent, then their measures are equal. That's what this says. So here it says congruent. Segments have equal measures. So remember, without the bar on the top, these mean the measure of segment AB and the measure of segment CD. And you can use that either way. You can switch the statement to its converse, switching the order, and it's still true and it's still for the same reason. Okay, so definition of congruence allows me to say if two segments are congruent, then they are equal. Definition of a midpoint. Well, here's the statement, the definition itself. If M is the midpoint of AB, segment AB, like this, I'm going to make a sketch here. So here's my segment AB. If M is the midpoint, then I know that segment AM is equal to segment MB. Okay? And therefore they're congruent by that definition of congruence statement we just looked at. If M is between A and B and AM is equal to MB, then you've satisfied the definition of a midpoint, and you can conclude then that M is the midpoint of segment AB. So if you show AM is equal to MB and M is between them, then it is the midpoint. You can make that conclusion, okay? So the if part of the statement is going to be like what one of these conditionals up here is the statement. Well, then the next step is the next statement. So if you want to move from congruence to equality, statement 1 might be that they're congruent, and then statement 2 would be that they're equal. And then the reason you make that statement is definition of congruence. So if you've got a midpoint, then all you have to do to state that AM is congruent to MB, you stop it. Stop your barking. Come in here and lay down. Sorry about that. The dog's barking here. Lay down. So if I've got a midpoint given to me, that might be statement 1. And then I can conclude statement 2. Like I can make statement 2 AM equals MB, and the reason I can put that down is the definition of midpoint. Or if I know that AM is equal to MB, then in the next statement I can say M is the midpoint. And my reason for that would be definition of midpoint. And here's the last one. It's called segment addition postulate. This is the betweenness postulate we worked on in the unit 1. Okay? So if B is between A and C, then AB plus BC equals AC. So I can get a mathematical equation into my proof using segment addition postulate, okay, or betweenness. So if you want to call this betweenness, you can do that instead of segment addition postulate, okay? Either one's fine with me. I prefer betweenness, okay? All right, so let's look at some proofs with this now. So a lot of proofs are going to have a drawing. And so the very first thing you want to do is you want to look at what you're given, and you want to write that down as statement 1. So we're given that segment AE and is congruent to segment DB. So that means these two long segments in the drawing are congruent, okay? Well, hopefully you're thinking to yourself, well, if they're congruent, they're also equal, okay? So for statement 1, I'm just going to list here that AE is congruent to DB, and I'm going to put C is midpoint of AE and DB. Okay? Now look what I'm trying to prove. I'm trying to prove that AC is congruent to CB. So I'm trying to prove that this segment is congruent to that segment. Well, in other words, I'm trying to show that those segments are the same length, right? So does it make sense to you that they're the same length? Because if I say C is the midpoint of AE, what's true about AC and CE? Well, they got to be equal. That's definition of midpoint. It's also the midpoint of BD, so BC's got to be congruent to CD or equal to CD, because that's also definition of midpoint. Well, then I know that segment AE, the whole segments are congruent. So if I've broken two segments of the same length in half, aren't all of their pieces going to be congruent then? Aren't all those halves going to be congruent? So really, all of these shorter segments in this figure, we're going to show eventually, are congruent. They're all equal in length, okay? But let's step through it formally. That's the key, is we're doing this formal process of saying all that I just did, formalizing and writing down your thought process, okay? So I've got to make a conclusion from what has been given. So when it says that AB is congruent to DB, there's only one place I can go. I can only go to AE, sorry, I don't want the bar on top, equal to DB. So this is given. And so why is that true? Well, that's using definition of congruence back here on that previous slide. If they're congruent, they're equal. So I'm going to put here def of congruence, like that, okay? Now, C is the midpoint of AE and DB. Well, I can write a couple things with that, okay? So I can write that AC plus, oh, sorry, not plus, AC equals CE, and I can write that BC equals CD, okay? And the reason I wrote that is because they told me right here that C was the midpoint. So I can make this conclusion now. So from this statement right here, I'm drawing this next statement, which is the conclusion of what a midpoint is. So my reason for that is by definition of a midpoint. Okay. Now how am I going to get from AC and CE to AE? Somehow I've got to make the leap from having pieces of segment AE to getting the entire segment AE involved in this thing. Well, we're going to go back to this segment addition postulate, or betweenness. It says the two small pieces equal the large piece. So I know that AC plus CE is equal to AE. And I know BC plus CD equals DB. And that's by betweenness. So I'm almost finished here. I need to get AC equal to CB. Oh, you know what? I think I put the... No, here's CB right here. So I need to somehow get AC equal to BC. Okay. So what can I do, class? What can I do here? Well, what do I know about AE and DB? I know they're equal. So I know that this statement, which is AE, and this statement, which is DB, are equal to each other. I can substitute them back in here, like this. AC plus CE equals BC plus CD. Okay? Now if I could just get to ACs and CBs only. Well, what's AC equal to? It's equal to CE. So I can put AC plus AC equals, I'm going to switch to CB plus CB. And then I know, okay, this is substitution. I substituted statement 4 into statement 2, like this. I put 4 into 2. Then I substituted again. I put statement 3 into statement 5. Okay? And now I have 2AC equals 2CB by addition. Or actually, we added those statements, we added those two things together, but more strictly what we did was we substituted 2AC for AC plus AC, so substitution. And then I just divide by 2, and I get AC equals CB. So division. Okay? Reese, stop it. Sorry about that. All right, that's a long proof. I wanted to show you a real formal long proof, okay? That's not what I want you to be able to do today, okay? But I'm just trying to give you an example of a healthy looking proof, okay? Here, let's try some that are a little bit easier here, all right? So we're going to put question statement 1 in here. Y is a midpoint, Z is a midpoint. Y midpoint of XZ and Z midpoint of YW. Well, if Y is the midpoint of XZ, let's go up here and mark some stuff on our drawing. If Y is the midpoint of XZ, that means this segment and this segment are congruent or equal, right? Okay. Then Z is the midpoint of YW. Well, YZ has already been marked with 1 mark, so ZW gets to be marked with 1 mark as well. And now in the drawing, you can see right here, XY is already congruent to ZW because I've marked them the same. So I just need to formalize what I just did. So the first thing I did was I realized if they tell me midpoint, what can I conclude from midpoint? Well, if I know something's a midpoint, I can conclude that 2 segments have the same length. That means XY has to equal YZ. Well, the same is true for Z. I saw that Z was a midpoint, so I need to make the statement that YZ is equal to ZW. And what was it that tipped me off that that was true? Well, I used the definition of midpoint. Okay? Now look at what's going on here. I've got XY equal to YZ. YZ is equal to ZW. Then what has to be true? Well, then XY has to be equal to ZW. And I just used the transitive property. Okay? And then I just need to go from equals to congruence. And so what is it that allows me to say if 2 things are equal, then they are congruent? Well, that's called the definition of congruence. Okay? Now we're going to look at some of the same things with angles. There's a definition of congruence for angles. If the angles are congruent, they have the same measure. If they have the same measure, then they're congruent. Okay, there's also the definition of an angle bisector. Well, this is like a midpoint for a segment. If you've got a ray that is an angle bisector, it creates 2 smaller congruent angles. So angle ABC gets split by ray BX. So then we get this ABX angle is congruent to XBC angle, the two smaller angles. And I can say if two angles are congruent, two smaller angles are congruent, then the ray must bisect the larger angle, okay? And then here's angle addition postulate, just like segment addition postulate. We had the betweenness, but in this case we can't say betweenness for angles. We're just going to say angle addition, okay? So that just says that two smaller angles like ABX plus XBC, they equal the large angle ABC in measure. Okay, so it's really just the same three statements except for angles instead of segments. All right? So if angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary, then angle 2 is congruent to angle 3. Okay? What's it mean if angle 1 and angle 2 are complementary? What's the definition of complement? Oh, let's write down our given first, class. So we're going to say 1, let's see here, angle 1 and angle 2 are comp. And then angle 1 and angle 3 are comp. Okay, so what's the definition of complementary? Let's use it. We're going to say measure of angle 1 plus measure of angle 2 equal 90. And the measure of angle 1 plus the measure of angle 3 equals 90. Okay? We just applied the definition of complementary. Now, look what I'm trying to do. I'm trying to get angle 2 and angle 3 on opposite sides of a congruence or equal sign. Well, here's angle 2, and here's angle 3. Is there any way I could put those on opposite sides of an equal sign? Well, yeah. This addition statement equals 90, and this addition statement equals 90. Therefore, they equal what? They equal each other. Measure of angle 1 plus measure of angle 2 has to equal the measure of angle 1 plus the measure of angle 3. And I just used substitution. Or I'd let you call transitive on that too if you wanted. Okay? Because you have two things equaling the same thing. 90 is the middleman there, right? Okay. Now, how can I get rid of my measure of angle 1s? There's one on each side. Well, I can subtract them. So I'm just going to subtract measure of angle 1 from both sides, and I get measure of angle 2 equal measure of angle 3, and I'm so close now. All I have to do is say angle 2 is congruent to angle 3 by that definition of congruence. If they're equal, they're congruent. That's the reason I can make that statement, okay? All right. You guys want to give this one a try? This one I think is a reasonable proof length for you at this point. Angle 4 is congruent to angle 7. Okay, so I know that 4 is congruent to 7. Why is it that 5 is congruent to 6? Well, what's true about 4 and 5? This is one of the things you have to examine. Now, notice I gave you something, and you could, about the only conclusion you could draw is the measure of 4 is equal to the measure of 7, but that's about it. So then sometimes you got to go to your drawing to get things involved, and hopefully you see that angle 4 is congruent to angle 5. And why is angle 4 congruent to angle 5? And why is angle 7 congruent to angle 6? Because they are vertical angles. And vertical angles are congruent. Well, I think we're just one step away. In place of 4, I'm going to put angle 5. And in place of 7, I'm going to put 6. And I just used substitution to do that. Okay? And I've got what I'm trying to prove. All right, so there's a practice lesson 3.6 geometric proofs worksheet. And then there's also a geometric proofs 2 worksheet. And I provided the answer keys with those as well.